Are we rolling? Okay, wonderful people. It is, let's see, Monday, Monday, October 30th, Halloween Eve. And in class today, we went over some pretty heavy stuff. And so this is a video that's going to show you how to work with polyatomic ions. This was the last worksheet that we have for this unit. And I want to show you how to combine these positive cations over here with what we call polyatomic ions, which are groups of elements that have a negative charge collectively with one another. You already know this skill. That's the good news. You just don't know that you know this skill because we've never done it with elements that look like, I'm going to try and point behind me real quick, like this one right here. The CO3 is all collectively together a group of atoms that have a negative charge. Okay, so this is the crisscross rule. You tired of seeing me do that in class? The crisscross rule. And by the way, I just had some fantastic beef jerky. My breath is horrible, so you're lucky that this is a video and not in real life. I'm going to show you how to combine these two, okay? That's a little bit of a blast from the past skill that we taught you earlier in the school year. So here we go. Let's start off with aluminum and this hydroxide ion over here, okay? We have oxygen and we have hydrogen that are bonded together, but collectively, as a whole, they function like they're one thing. So I know your eyes are telling you there's two things here, and there are. Just pretend that they are one thing grouped together, and it makes this whole process so much easier, okay? Remember, aluminum has a positive 3 charge here because it gave up 3 valence electrons. This hydroxide here has a negative 1 charge because it wants to gain 1 valence electron. And the only way that these are going to bond is if we get them in the right ratio, okay? Aluminum's got to get rid of 3, but this grouping right here can only accept 1. So we're going to need more of these groupings in order for these two to bond properly. So our crisscross rule goes like this. We know our answer has to have aluminum, so write it. Write it right away. Aluminum, okay? And we know our answer has to have OH. Don't mess with the order. Don't change the number. That number of each atom that we have, just leave it exactly as it is, OH, and now we're all primed and ready to go to do our little crisscross rule. This 1 here, without a charge on it, comes down and applies to the hydrogen. So I'm going to move that 1, and it goes right here. Remember, when it's a number 1, you don't have to write it. When you write aluminum, we assume that there's at least 1 atom of aluminum there, okay? But we're writing it just so you can see where that number came from. The 3 on aluminum gets applied down here to this hydroxide, right? Just like that. But the problem is when we write it like this, the 3 looks like it belongs to the H. And we need the 3 to belong to that whole package deal, the O and the H at the same time. So even though we can't break those apart or stick any numbers in between here, what we can do is use parentheses, okay? You can put parentheses around it. And as you remember from the very first skill we taught you, when we were counting atoms, this 3 now applies to everything inside of here. And we have correctly written the formula with this polyatomic ion. Okay? If that wasn't good for you, let's try this one. Aluminum, again, with the same +3 charge. It's +3 because it gave up or got rid of 3 valence electrons. Over here, we have CO3. We've got carbon and 3 oxygens that are bonded together. And collectively, as a whole, as a group, together, as one thing, they have a charge of -2. So aluminum is looking to get rid of 3 valence electrons. CO3 over here is looking to gain 2 electrons, which sounds like a good deal, but we can't have any extra electrons around that are not accounted for. So we've got to use our crisscross rule in order to find the right ratio. So how do we start off? Always the same way. Write what you know has to be part of your answer. Your answer has to have aluminum in it. There's my aluminum. And my answer has to have CO3, okay? I can't mess with that. I can't unpackage it in any way. It has to show up in my answer exactly as it looks right there, okay? Don't let that 3 bother you right there. Now let's do our crisscross rule. The 2 applies to the aluminum. So I'm going to write it right there. The 3 needs to apply to everything here. And the only way to group those together without changing them is to put parentheses in there. Okay? That's allowed. It's totally okay. And even though I already have a 3 here, remember that was part of the original package deal, I have to bring this 3 down here and represent that we have 3 of everything in there. Okay? It looks like a lot, it looks complex, but it's still the same old crisscross rule that we taught you before. All right? Try that worksheet out. If you run into some problems, bring those questions to class, and we'll work through them. I'm going to eat some more beef jerky. So